Welcome to ZoomInData. Hello everyone. Thank you for joining Azure Logic Apps series. In this session, titled Building Intelligent Multi-Agent Systems with Logic Apps and Azure AI, we will cover core concepts of multi-agent systems and why they are the future of intelligent automation. How Logic Apps orchestrates autonomous, conversational, and collaborative AI agents. The Model Context Protocol, MCP, and how to publish workflows, connectors as reusable AI tools. Step-by-step patterns for hierarchical versus peer-to-peer agent coordination, handoffs, and real-time adaptation. End-to-end demo and best practices, 2026 edition. This topic represents the cutting edge of Logic Apps, combining traditional orchestration with autonomous AI agents to create truly adaptive enterprise solutions. If you find this content valuable, please subscribe to ZoomInData and enable notifications to stay updated. Let us begin. What is a multi-agent system in the context of Azure Logic Apps? A multi-agent system consists of multiple specialized AI agents that collaborate, hand off tasks, or operate in hierarchy to solve complex problems. Logic Apps acts as the orchestration layer, triggering, coordinating, and monitoring agents. Agents can be autonomous, decision-making, conversational, chat, or tool using calling connectors, workflows. How does Azure OpenAI integration enable multi-agent systems in Logic Apps? Azure OpenAI connector provides chat completion, function calling, and embeddings. Function calling allows agents to request tool execution, example call Logic Apps actions, external APIs. Logic Apps maintains conversation state, Cosmos DB, variables, and routes between agents. What is the Model Context Protocol, MCP, and how does Logic Apps support it? MCP is a standardized protocol, introduced, enhanced 2025-2026, that lets AI agents discover and consume tools, services uniformly. Logic Apps workflows and connectors can be published as MCP servers, new 2026 feature. Agents in Azure AI Studio or Copilot Studio consume these tools securely via Azure API Center. How do you publish a Logic Apps workflow as an MCP server? In Azure Portal or VS Code, select Workflow. Publish as MCP server, standard model required. Define input, output schema, authentication, managed identity preferred, and description. Azure automatically generates OpenAPI compatible MCP endpoint. Register in Azure API Center for governance, discovery, and subscription. What are the main types of agents you can orchestrate in Logic Apps? Autonomous agents make decisions and take actions without human input, e.g., route tickets, approve low-risk orders. Conversational agents maintain context across turns, example, customer support chatbot. Tool-using agents call connectors, functions, or other workflows via function calling. Supervisor agents coordinate multiple sub-agents, hierarchical pattern. Explain hierarchical versus collaborative multi-agent patterns in Logic Apps. Hierarchical, supervisor agent, delegates to specialist agents, example, classification, analysis. Action, collaborative, peer agents work together, example, one summarizes, another validates, third decides. Logic Apps implements both using scopes, conditions, and state management, Cosmos DB or variables. How do you implement handoff between agents in a Logic Apps workflow? Use state store, Cosmos DB, Dataverse to parse context, conversation history, task status. Supervisor agent decides next agent, calls HTTP or functions connector to invoke it. Receiving agent reads state, processes, updates state, returns control or terminates. What is real-time adaptation in multi-agent systems? Agents change behavior based on runtime feedback. Example, user correction, new data, error. Logic Apps enables this with loops, until condition, dynamic prompts, and state updates. Example, customer chatbot, detects confusion, hands off to human or senior agent. How do you maintain conversation state across multiple agents? Store state in Cosmos DB, partition key equals conversation ID, or Dataverse table. Each agent reads, updates state on entry, exit. Include history and prompts to preserve context. Token limit management important. What role does function calling play in agentic workflows? OpenAI model returns function call request when it needs a tool. Example, check inventory, send email. Logic Apps executes the function, connector, HTTP, inline code, returns result to model. Model continues reasoning. May call more functions or generate final response. How do you implement error handling and recovery in multi-agent systems? Use scopes for each agent. On failure, compensating branch or retry. Supervisor agent monitors sub-agent status. Escalates or restarts on timeout. Log agent decisions and state changes. Alert operations on repeated failures. What security considerations apply to multi-agent systems in Logic Apps? Use managed identities for all Azure service calls. OpenAI connectors. Apply content safety filters on prompts, responses. Use Azure API Center to govern MCP servers. Enforce policies and subscriptions. Limit agent tool access with least privilege RBAC. How do you monitor and observe multi-agent workflows? Azure Monitor plus Log Analytics. Track agent handoffs, decisions, failures. Application Insights. Standard. End-to-end tracing across agents and tools. Custom logging. Each agent writes decision plus state change to Log Analytics. Power BI dashboard for agent performance and escalation rates. What are common use cases for multi-agent systems in Logic Apps? Customer support, classify ticket, sentiment agent, resolution agent, escalate if needed, order fulfillment, validate order, fraud agent, inventory agent, shipping agent, document processing, extraction agent, validation agent, approval agent. How do you test multi-agent workflows effectively? Unit test individual agents, mock tools, fixed prompts. Integration test, simulate handoffs with sample conversations. Chaos test, inject failures, timeouts, bad responses. Verify recovery, A/B test prompt versions in production with traffic splitting. What are the latest multi-agent enhancements in Logic Apps, as of 2026? Native MCP server publishing from workflows, connectors. Built-in supervisor patterns and handoff actions. Better state management actions for conversation persistence. Enhanced integration with Azure AI Studio Agent Playground. How do you manage token usage and cost in multi-agent systems? Cache frequent responses, embeddings in Redis or Cosmos DB. Use smaller models, GPT-4o Mini, for simple agents. Reserve premium for critical steps. Batch function calls where possible. Monitor token consumption via Azure Monitor Metrics. What governance features exist for multi-agent systems? Azure API Center governs MCP servers, discovery, subscription, policies. Azure Policy enforces responsible AI, content filters, model approval. Audit logs track all agent decisions and tool calls. Human in the loop mandatory for high-risk actions. How do you scale multi-agent systems in Logic Apps? Use standard model for dedicated resources and higher concurrency. Parallel branches for simultaneous agent execution. Auto-scale functions for tool calls. Distribute load across multiple Logic Apps instances via Event Grid. Why is multi-agent knowledge important in interviews? Interviewers ask, design an intelligent support system with multiple AI agents. Tests understanding of agentic AI, orchestration, state management, and responsible AI. Shows forward-thinking skills. Multi-agent is a 2026 plus enterprise trend. What final recommendation would you give for building multi-agent systems? Start with single-agent, add collaboration gradually. Make every agent idempotent and observable. Use MCP for reusability and governance. Always include human oversight for high-stakes decisions. Monitor token usage and agent performance closely. Thank you for watching this detailed session on building intelligent multi-agent systems with Azure Logic Apps and Azure AI. If you found this video helpful, please like, share, and subscribe to ZoomInData. More advanced Azure Logic Apps content is coming soon. Stay connected and keep learning. See you in the next video.